Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. If there were 39 people on the bus and 4 people got off the bus, that would leave 35 people remaining on the bus. So the fraction of people staying on the bus is 35 out of the 39 people on the bus. So our answer is, as a fraction, 35 over 39. We can't cancel that any further. If I split this shape into 2 sets of 6 blocks, when we're asked to shade in 3/6, for each one of those, or each set of blocks, I'm going to shade in 3 of the 6. So that's 3 for the first set, and this is 3 for the second set. And that's our answer. Now you might notice that 3 over 6 is the same as a half, because we can divide on 1 by 3, and so all I need to do is shade in a half. Or you might convert 3 over 6 into 6 over 12, and there's 12 squares altogether, so it's 6 of the 12 squares. There's lots of ways of doing this question. I'm going to start just by copying out the question. So we've got x over 12 equals 4, and when we're asked to solve, it means we need to find out what x is. We need x equals, and the method for doing it is just by putting lines either side of the equal sign, our solving lines. And what we need to do is we need to get x on its own on the left hand side. What's stopping x from being on its own? This over 12. What does over 12 mean? Well, it means divide by 12. So how do we get rid of it? Well, we do the opposite, the inverse of divided by 12. What is the opposite of divide by 12? Times 12. Now these lines show us that whatever we do on the left hand side, we have to do on the right hand side. So we have to times 12 both sides. So on the left hand side we're left with x, on the right hand side we do 4 times 12, which is 48. So our solution is x equals 48. To find the mean, we need to find the sum of the numbers and then we need to divide that by the amount of the numbers. Sum is just a fancy way of saying add up the numbers. So we're going to do the 3 plus the 8 plus the 10 plus the 2 plus the 8 plus the 12. And we're going to divide that all by how many numbers there are. So there are 1, 2, 3, 4, 5, 6 numbers. When you add those numbers up, you get 43. And then when you do 43 divided by 6, you get 7.166 blah blah blah. Now the question says it wants it to 2 decimal places, so we're just going to round that to 7.17. To answer this question, we basically need to find the lowest common multiple of the 10 minutes here and the 15 minutes here. So we're going to start off just by doing the 10 and 15 times table, so it'd be 10, 20, 30, and 15 times table would be 15 and 30. So the lowest common multiple is 30. So after half an hour, these buses will sync up. They'll both leave at the same time, and all buses start service at 9 o'clock. So it will be half an hour after 9 o'clock, which will be 9:30. So firstly, we're going to work out what the percentage increases are as a multiplier. So we start off with 100%. Jane has a 1.2% interest pay rise, sorry, and so that would be 101.2%, and we divide that by 100 to make it a multiplier. The multiplier is 1.012, so we get the 20,000 times it by 1.012, and that gives us 240. Next we do the same for Lenny, so that is Jane. And so let's do Lenny. And so that's 100% plus the 1.5% will be 101.5%. Make that a multiplier, 101.5%. We divide that by 100, which gives us 1.015. And then finally what we do is we get the 17,000 times it by the multiplier. And when we do that, we get 255. So Lenny has 255, Jane has 240. So it says which of the employees has a larger pay increase and by how much. So the answer will be Lenny, and it's by £15 because that's the difference between these. So with a stem leaf diagram, the numbers in the middle often represent tens. They could be units. So we look at the key first of all, and we see that 3 line 9 means 93. So the numbers in the middle are going to represent 10. So this is a 90. Now we're looking for English, so this will be 92. So our first number will be 92. Then this will be 10 tens and a 4. So it would be 104. 11 tens and 1, so 111, and then 11 tens and 2. So to find the median, we go cross out the biggest and smallest until we're left with 1 or 2 in the middle. Here we're left with 2. So what we're going to do is we're just going to add the 104 to the 111, and we're just going to divide that by 2. So when we do that, we get 107.5 or 0.5. So our answer is 107.5. To find the midpoint, we can use this simple formula. And we're going to start off by finding the midpoint for the x component. And the formula is just adding the 2 x coordinates and dividing by 2. So we're just going to add the 2 x coordinates together. So we've got 2 plus minus 1 divided by 2. And that's going to be 1/2. 0.5. Could do the same thing for the y coordinates, and the formula is the same, but just with adding the y coordinates together and dividing by 2. So it's going to be -5 plus 2. All of that divided by 2. So that's going to be -3 over 2, or -1.5. Bearings are always from north and go clockwise. So let's have a look at where the north line is. Well, the north line is here. And to find the bearing of B from A, so that means we're at A and we're looking at the angle of B, we're going to go clockwise. And you can see on the diagram it's already labelled as 42 degrees. But the third rule of bearings is they must be 3 digits. So instead of 42, it's going to be 0, 4, 2. So we've got to first of all work out how many parts there are altogether. So oil has 21 parts, vinegar has 5, so altogether there's 21 plus 5, which is 26 parts. Now how many of those parts are vinegar? Well, vinegar is the second one, so it's going to be this 5. So vinegar has 5 out of the 26 parts, or a fraction would be 5 over 26. To work out the mean, what we need to do is work out the sum of the numbers, basically add them all up and divide that by the amount of numbers. Now, when we're giving the numbers in a frequency table, it's a little bit more tricky to find the sum of the numbers and the amount of the numbers, but there are some really strong techniques. The first thing I want to just highlight is that a frequency table is just saying that there are 5 lots of 4. So we can imagine writing out 5 lots of 4. Okay, and then there are 10 lots of 5. So you can imagine writing 10 lots of 5. I'm not going to, but that's all a frequency table is saying. Okay, so how do we work out what the numbers will add up to? Well, let's look at those 4s. How many 4s are there? Well, there's 5 of them. And what are 5 4s? Well, to work that out, we just times them. 5 4s are 20. So we create this FS column, S for sweets. Okay, and what that's telling us is all of those 4 sweets added together are 20. If we keep going through this, there are 10 lots of 5, well that just makes 50. 5 lots of 6, which is 30. 8 lots of 7, which is 56. And then 2 lots of 8, which is 16. Now altogether, what do they add up to? Well, we know these add up to 20, these add up to 50, these add up to 30, etc, etc. But altogether, they're going to add up to whatever this column adds up to. And we can show that as a kind of sigma fs. And we just add up the 20, 50, 30, 56, 16. So we add up that column, which is going to be 172. So we know the top is 172. Now the second part is to work out how many numbers there are. Well, there are 5 numbers in the first column, 10 in the second column, 5 in the next row I should say, 8 in the next row, and then 2 in the next row. So to work out how many there are in total, we just add those up, and we call that the sum of F column. And we do 5 plus 10 plus 5 plus 8 plus 2, add those together, which is 30. So all we need to do to work out the mean is 172 divided by 30, which is going to be 5.733 blah blah blah. It wants it to 2 decimal places, so what we're going to do is just round that to 5.73. So we can quickly draw a line of best fit for here, and it looks something like that. And if our line of best fit is increasing like we have here, then we say the data is positive. If, however, the line of best fit is decreasing and looks like this, we say that it's negative correlation. So positive if it's going up, which this one is, so it's a positive correlation. And if it's going down, then it's a negative correlation. If the data is all over the place, so it looks like something like this, where you've got the points everywhere, we say that's no correlation. So the only way of answering this question is to work out what these are as ordinary numbers. And so 7 times 10 to the power of 7 would be 7, 1, 2, 3, 4, 5, 6, 7. And 9 times 10 to the power of 4 would be 90,000, so that would be 9,000,000. And so we're just subtracting them like that. And so we'll get 6991000. And obviously if this is on the calculator paper, just type it into your calculator. There are no tricks here. You can't do anything with the 7 and the 9. You're not subtracting powers or anything. You're just literally typing in what it says. And there's a button on the calculator like that you will need to use. So if you don't know what that is, ask your teacher or ask someone to help you out with that. So when we say y is directly proportional to x, what we mean is whenever x doubles, y will double. Whenever x halves, y will halve. Now we've got this proportionality sign here, and to make that an equals, all we need to do is introduce a k constant to the right hand side. So it's y equals something times x. Now to find out what that something is, to find out what that constant is, what we're going to do is feed in the value of y and the value of x that we have. So we're going to feed those in. So y is 55.3 and x is 7. So it would be 7k. And we're just going to put our lines in and solve this. So it's going to be divide by 7 both sides. And 55.3 divided by 7 is 7.9. And that's what k is. So we're going to rewrite this equation here, this formula here. Y equals 7.9 x, and that is actually our answer. We have our everything list here. Now these are all the numbers that go into our Venn diagram. And in A is all the square numbers. So we're going to have a look and see which square numbers we've got. Well, we've got 1 and we've got 4 and we've got 9 and we've got 16 are all square numbers. So in here is 1, 4, 9 and 16. And we're going to look at all the odd numbers. So we've got 3, we've got 17, we've got 1, and we've got 9. Now in both the lists we've got the 1 and 9, so that's going to go in the middle. Just the square numbers are 4 and 16, and just the odd numbers are 3 and 17. Now notice we've got the 2 and the 6 there, and those will just be on the outside. So factorise means to put it into a bracket, and it looks like it's a quadratic here, but it's actually just a linear factorising because we don't have a number term. So we're going to just use one bracket for this. And looking at these terms, I'm going to focus first on the numbers. So 20 and 30, I can divide both of those by 10, and that will leave 2 and 3. So that's the numbers done. Next I'm looking at the t terms. So we've got t squared there and a t there. So we can divide out a t, but that will leave a t on the first term. And finally I'm going to look at the u, and there's just a u on both of them I can factorise out, and actually that just leaves nothing on the inside of the bracket. Now always when you do this, expand the bracket to check if you've made any mistakes. So I'm going to do smiles and rainbows. There's loads of different methods. So 10 times 2 is 20, t times t is t squared, and then the u, plus 10 times 3 is 30, times t times u. So we know we've got the right answer. So our answer is 10tu brackets 2t plus 3. We can't work out what x is straight away, but we can find this value here. And we know with Pythagoras we can find a third length if we've got other two in a right angle triangle. So a squared plus b squared equals c squared. And a and b were labelled. C is always opposite the right angle, so it'd be 49 squared plus b squared equals 68 squared. And 49 squared is 2401. And 68 squared is 4624. So we are solving here, so let's get our lines down. And we're going to start by subtracting the 2401 from both sides. So we've got b squared equals 2223. Then we're going to square root both sides, and we've got b equal to 47.148, blah blah blah. Okay, we're now looking at the second diagram, and this time we're going to have a, we've got our b, and we're going to call x the c. So it'd be a squared plus b squared equals c squared, but this time a is 39. B we are given as 47.148, we've just worked that out. And we're looking for c, in fact we can call it x now. Okay, so we need to square that. So we do 39 squared plus 47.148 squared, and that will be 3744 equal to x squared, and we'll just get our lines in because we need to square root both sides, and we get 61.188 blah 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 is equal to x. It says it wants its two decimal places, so that will be 61.19. To go from meters to centimeters, we obviously times by 100. But to go from meters squared to centimeters squared, we times by 100 per dimension. Now, whenever we talk about things in meters squared, we're talking about areas which have 2 dimensions. So we times it by 100 squared. So when we've got a 2 meters squared here, we times by 100 squared to get it into centimeters squared. So that's going to be 20,000. To find solutions for quadratics on a graph, all you need to do is find out where the graph meets the x-axis. Okay, so the coordinates this graph meets the x-axis are here and here, and that would be minus 0.8 and minus and 0.2, and they're also called roots. So the first thing I notice is the second equation isn't really in the normal format for doing simultaneous equations. So I'm just going to rearrange it so that we have it where we want it to be. And I'm just going to put my lines in so I can rearrange. So the first thing I want is the x's and y's on the same side. In fact, actually all I need to do is take away 4y from both sides, and we get 5x minus 4y equals minus 7. Okay, so what we do now is we put both our equations down so we can solve these simultaneously. So 5x minus 4y equals minus 7. And you notice the coefficient of the y is already the same, so we don't need to multiply anything. But the signs are different, and the d in different is the d in add. So we're going to add going downwards. So we're going to add everything. So we're doing 3x plus 5x, which is 8x. 4y plus minus 4y is nothing, which is good, because we want to get rid of that. And 47 take away 7 is 40. All right. Let's put our solving lines in, and we're going to divide by 8 both sides. So we get x equals 5, and we're going to substitute that value into one of the equations. I'm going to pick this top one. So instead of 3x, we're doing 3 times 5 plus 4y equals 47. Get my solving lines in. So that will be 15 plus 4y equals 47, and then we're going to take away the 15 both sides, and so it's 4y equals 47 take away 15, which is 32. Divide by 4 both sides, and we get y equals 8. Now we can check that using this equation here. So 5 times 5 is 25, take away 4 times 8, which is 32, is minus 7. So we know we've got it right. There are a few different ways you could answer this question. I'm going to do it with a tree diagram, but you didn't need to draw a tree diagram to answer this question. So we've got our first tree, which is our first bus. And the choices are male and female. And we've got our second kind of branch, I suppose. And it's still male and female. And this is our second bus. So the property of male on a first bus is 9 over 15. And therefore the property of female is 1 minus 9 over 15, which would be 6 over 15. Male on the second bus is 7 over 15. And so female would be 8 over 15, because they need to add up to 1. And it's independent, so these will be the same. And the question is basically asking what is the probability that both will be female. So to have both female, we need to have gone down this line at the start, and then this line again. Okay, so looking at the fractions along the way, it's 6 over 15 and 8 over 15. The word "and" in probability means times. So whenever you're finding the probability of getting to an outcome, so this outcome will be FF, because they're both female, you are multiplying the fractions that you go across. So it would be 6 over 15 times 8 over 15. So 6 times 8 is 48. And times the bottoms, 15 times 15 is 225. Now you can actually cancel that down. So what you can do is you can divide top and bottom by 4. And that will give you 16. Is it 4? No. You can divide top and bottom by 3. And that would be 16 over 75. So either 48 over 225 or 16 over 75. To find the resultant vector, we just get the two vectors and we add the tops and add the bottoms. And it's a plus minus 13, so it's 9 take away 13. When we do that, we get 13 at the top and minus 4 at the bottom. When drawing a quadratic or a cubic or reciprocal graph, you've got to make sure that you find as many coordinates as you can with curves. With a linear graph, the minimum you need is 2, and we normally take 3 coordinates. With a curve, we need loads. So I'm going to pick loads of x coordinates. So I'm just going to pick all of the integers. Lots and lots. And I'm going to find out what the y coordinate is. So for the first one, I'm going to put in, on my calculator, a quarter times brackets minus 4, close brackets, plus 4, and all of that in brackets. Then I'm going to do the second bracket. So I'm going to put bracket minus 4, close bracket, minus 1, close bracket. And then bracket minus 4, close bracket, take away 4, close bracket. Okay? So I'm just going to put in bracket minus 4 each time you see an x here. When you do that, you get the answer of 0, which makes sense because minus 4 plus 4 is 0, and whenever you times something by 0, it will get to 0. Then I'm going to do the same with minus 3, and I get 7. Same with minus 2, I get 9. Same with minus 1, I get 7.5. Same with 0, I get 4, and 0. Then minus 3, then minus 3.5, and at 4 I get 0, then 9, and then 25. Now that last one, the 25, is not really that helpful because the axis only goes up to 16. So the next thing is I'm going to plot them. So minus 4 is at 0, so that will be here. Minus 3 is at 7, so that's going to be halfway here. Then we're at 9, which will be halfway here. 7.5 is a bit more interesting because it's halfway between 7 and 8. So it would be about here. Then 4. Then 0. So it looks like it's going to go down now, but it's going to go down for a little bit. Like down here where it's minus 3, and even further down here where it's minus 3.5, but then it starts going up again. So 0, and then 9, and then we're off the top. So the next thing we need to do is join that. Now it's sometimes easier if you turn the page sideways, depends on the curve. I can't turn this sideways, so mine's hopefully gonna look okay. And it's one continuous curve going through all the points. And so we're going to try our best here. And it's not easy for me because I can't quite see the points. You shouldn't take your pencil off at all. Just I have to because my hand gets in the way. And then we know it shoots up from here. Now, that doesn't look the best curve in the world, but as an examiner, what am I looking at? I'm looking at the fact that it goes through all the points, which it does. I'm looking at the fact that there's no obvious gaps, which there isn't. it stops here, but it goes off the top of the graph here, so that's fine. I'm looking for no feathering, which is where you do kind of that with the pencil. No, there's no feathering there. There's a little bit of a wavy bit there, but I think a lot of students get worried that they're going to lose marks unless it's perfect and they start rubbing it out. Like if you've missed a coordinate and you've kind of gone around something, then yeah, maybe rub it out. Or if you've got feathering, or if it just goes, if you knock your hand and it goes off or whatever. But unless it's awful, unless it's not going to get the marks, just leave it. If it's a bit wavy, if it's a bit weird round here, and I think, you know, it's not perfect around this bit either, don't worry about it, leave it, it will still get the marks. Yes, this one doesn't quite go through the coordinate, but it's close enough. And, you know, I think that students often, when I'm marking, I see that they've rubbed it out several times, and where I can see it still there, it was fine. It was going to get the marks regardless. And so it's wasted time, and it just makes it look a bit messier. So it doesn't have to be perfect. Acceleration is change in velocity over change in time. So change in velocity where it starts at 0 and goes up to 150. So that would be 150. Over the change in times. Well, the time starts at 0 and goes up to 5, so that's 5. And so 150 divided by 5 is 30. The velocity is in meters per second, the time is in seconds, so the units will be meters per second squared. So it's 30 meters per second squared. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.